Today we are going to discuss short answer type questions from the chapter Permutations and Combinations. Now in this video I am going to cover 9 questions. 9 questions only. So the questions are rank, depending on the rank. We have 3 questions, master, present, MSET, and these questions are related to the sum of all 4 digit numbers. One is 0 is not included and the other one is 0 is included. Next one, these are from combinations, selections of the team, and next question is also selection, and these two are results related to the NCR related questions. So let us start from the rank. The first question is rank of the master. So to need the rank means that the letters of the word are arranged in alphabetical order, dictionary order. So we have to get that after how many words we'll get the word master. For this one, the procedure is first we need to arrange the letters of the master in alphabetical order. The alphabetical order of the given word is A, E, M, R, S, T. This is the alphabetical order. We need the word master rank. In dictionary order, first we have the words that begin with the A, right? Number of words, first we have the words that begin with A. Number of words begin with the A. So when A is started, how many letters are there? 6 letters are there. A is in the beginning, right? 5, right? This is equal to, so when A is here means that we have 5 more letters. This can be arranged in 5 factorial ways. So let us write it. Number of words begin with A. 1, 2, 3, 4, 5. 5. That is equal to 5 factorial. That is equal to 1, 2. So after we are done with the words starting with A, in dictionary order we have number of words that begin with E, right? So we have 1, 2, 3, 4, 5. Those are also 5 factorial, that is 120. So after we are done with the E, then we have the words that begin with M, but M is required, right? Because we need the master rank. So M is required. Whenever the required letter is there, we have to lock that and we have to come forward. So when M is locked, we have to come forward. That is A. So A is also needed. Lock this one also. Again come forward. Next we have the word, the words that begin with MA. E is there. So 1, 2, 3. How many are there? 3 factorial is there. 6. Next, after we are done with MAE, M and E are locked. Now after E, which letters we will have? R, right? MA, R. 1, 2, 3. So how many are there? 3. So that is 6. After we are done with these things, M locked, A is locked. After R is done, S is needed, right? So we have to lock that. So when S is locked, again we have to come forward. We have E. So that is 2 factorial only. That is 2. Number of words that begin with M, A. After S is also locked. After E, we have R. So R is not needed, right? R. We have 2 factorial. That is 2. After R is done, we have S is already used. So T is there. So M, A, S is also locked. After R, then we have T, right? T is locked. Come forward, E is also locked, E is also required. So that is 1. That is one factor, that is 1. That is all these three things. That is equal to 120, 120, 240, 240, 240, 250 to 257. So the rank of the word master is equal to, so rank of master is equal to 257. Now let us go for the next word. Second question, prison. Prison rank is needed. So alphabetical order should be written. Alphabetical order. What is that? I, N, O, P, R, S. So similar to the previous question, number of words that begin with the first I, right? I. When I is there, 1, 2, 3, 4, 5, right? That is 5 factorial. That is 120. After we are done with the words that begin with I, so next letter is N. Number of words that begin with N occurs. 1, 2, 3, 4, 5. That is equal to 5 factorial. That is equal to 120. After N are done, then the number of words that begin with O happens. So that is equal to 5 factorial. That is 120. After that P is there. So but we need P. Number of words that begin with P is locked here. Come forward I. 1, 2, 3, 4. That is equal to 4 factorial. That is equal to 24. Number of words that begin with P is locked. After that P, N is there. After I we have N only. Right? 1, 2, 3, 4. That is equal to 4 factorial. That is 24. After the words are done with Pn, we have PO. P is locked. O. 1, 2, 3, 4. That is equal to 4 factorial. That is equal to 24. After PO is done, R is there. Number of words begin with P. Come forward R. R is also needed. Lock that. I is needed. I is also locked. Next we have N. So we have only 4 letters are there. 6 letters. So this is equal to 2 factorial. That is 2 only. Next one is that P is locked. R is locked. I is locked. After N we have O. 2 letters only. That is 2 factorial 2. Next number of words that begin with P, R, I. After I is done, O is done, right? P is also done, R is done. Next one is S only. S. Come forward. I is used. We have S only. That is 1 factorial. That is 1. Next one, last one, number of words that begin with P, R, I, S. After N, next one is O. We needed that. Yes. That is 1 factorial. That is 1. Let us add everything. 360 plus 72. So 432 plus 6, 438. Therefore rank of prison equal to 438. Let us go for the next question. Rank of M set. We should be careful in doing this one. First let us write the alphabetical order. Alphabetical order. What is that? A, E, A, C, E, E, M, T. So we need M set rank, right? So number of words that begin with number of words that begin with first A, right? So how many are there? 1, 2, 3, 4, 5. Remaining 1, 2, 3, 4, 5, right? 4, 5 are there. Out of these 5, 2 E's are there, right? When similar things are there, we have to divide by 2 factorial. That is equal to 60. After we are done with the C, so number of words begin with the C. So that is equal to, how many are there? 2, 3, 4. That is equal to 5 factorial by 2 factorial, that is also 60. So after that, done with this one, E is needed, right? First letter. Number of words that begin with E. E is locked. Come forward. A is also locked. Come forward. C. How many letters are there? 3. If E is C, EA is are fixed. We have C, E, empty. Those are different, right? So we have to write that one as how many are there? 3 factorial. 3 factorial means 6. So number of words begin with E is locked. A is locked. After C is there, we have again E, right? So how many are there? These are also 3 factorial. This 6. After this one, number of words that begin with E, A. After E we have M. M is needed, right? Come forward. This is locked. A is there. A is already used, right? So we have to use A is used means that we have C. Come forward. E is also needed. T, that is one factor, that is 1. So what is this one? 120, 133. Therefore rank of M set is 133. Before going to the next question, we have to learn 2 notes. So just applying the formula only. Find the sum of all 4-digit numbers, right? So remainder is the first one. The sum of r-digit numbers. First one. The sum of r-digit numbers that can be formed using the digits. That can be formed using the given n distinct digits. Using the given n distinct digits. So 1 lesser than n lesser than 9. So the thing is 0 in this one. Is formula is n minus 1 pr minus 1 into sum of the digits into 1 1 1 and so on 1 r times. This is when there is no repetition of what is that? 0 is there. So now let us do the fourth question now. So in the fourth question, what we have is that n is equal to 5, r is equal to 4. In the exam you have to write the formula also. Therefore, the sum of all 4-digit numbers that can be formed using the given digits. 1 3 5 7 9. So that is without repetition is n minus 1 p r minus 1, r is 4 here, into sum of the digits 1 plus 3 plus 5 plus 7 plus 9 into 1 1 1 1 r times. R is 4 here. So that is equal to 4p 3 times of what is that sum of this one? 25 plus 125 into 1111. So what is that? 24 into 25 into 1111. So 24 25 are 600 into what is that? So that will be equal to 66660. So next question is fifth one. 0 is included in this. If 0 is one among the given n digits, then the sum of the r digited numbers that can be formed using the given n distinct digits, formed using the given n distinct digits 0 lesser than n lesser than or equal to 9 is formula is n minus 1 p r minus 1 into sum of the digits into 1 1 1 1 and so on 1 r times minus 10 minus 2 p r minus 2 into sum of the digits into 1 1 1 and so on 1 r minus 1 time. This is r times, we go with r times, this is r minus 1 times. In this question, number of digits n is equal to 5, r is equal to 4, 0 is included. Therefore, the sum of all 4-digit numbers that can be formed using 0 to 478 without repetition. Is 5 minus 1 p r minus 1, the sum of the digits 0 plus 2 plus 4 plus 7 plus 8 into 1 1 1 1 4 digits minus 5 minus 2 p 4 minus 2, the sum of the digits into 1 1 1 3 times, so that is equal to 4p3, that is 21 into 1 1 1 1 minus 3p2 into 21 into 1 1 1, 24 into 21 into minus 6 into 21 into 111, that is equal to, if we calculate the 5,45,958. Done. So we are done with the 5 questions. Next we are going to the combinations. In combinations, the first question is, let us check that which question we did. So fifth one is done, right? Sixth one, 6 Indians, 5 Russians. Let us go for the next one. Sixth one, how many Indians are there? 6 Indians, right? Let us make a table with this one. Indian 6, Russians 5, number of selections. One, see this one. From 6 Indians and 5 Russians, 5 members are selected such that majority are Indians. Majority of Indians mean that so 5 member selection only, right? 5 members are selected. 5 mean that, let us take Indian 3 and 2 Russians. India are majority. Let us take 4 Indians, 1 Russian, or 5 Indians, 0 Russians. So maximum we need to select only 5 members. So we are done, right? So number of selections becomes, out of 6 numbers, 3 Indians are selected. That can be done in 6C3. Out of 5 Russians, 2 are selected. That can be done in 5C2. So this is equal to 6C3 mean that 6 into 5 into 4 by 3 into 2 into 1. So if we calculate that, that is 200. Similarly 6C4 into 5C1. So that is equal to 75. 6C5 into 5C0, that is 6 only. So required number of selections is equal to required number of selections or total number of selections is equal to 200 plus 75 plus 6, 281. Next one is seventh one. From 7 batsmen, 6 bowlers, 11 members team should be formed. So how many batsmen? 7 batsmen, bowlers 6 bowlers, number of selections. Number of selections. So out of the 6, at least from 7 batsmen, 6 bowlers, 11 members team can be selected, having at least 5 bowlers are there. 5 bowlers are there, 5. So 6 bowlers can also be there. So number of selections is equal to 7C 6 into 6C5, one selection. Next one is 7C5 into 6C6. So what is this value? Is 42, 21. So total number of selections is equal to total number of selections is equal to 42 plus 21, that is equal to 63. Next question is 8th one. For 8th one, we continuously use NCR plus NCR minus 1 is equal to N plus 1 CR. So the question is 34C5 summation R is equal to 0 to 4, 38 minus RC4. So we have to substitute here C values, R values, right? I'm substituting R is equal to 4. Actually we have to substitute 0, 1, 2, 3, 4. But it is better to substitute from 4. As it is sum only, we can substitute it. 4 is substituted, 34 C4. 5 is substituted, 33 C4. Next 4 is substituted, this is wrong. 3 is substituted, 35 C4. 2 is substituted, 36 C4. 1 is substituted, 37 C4. 0 is substituted, 38 C4. Once observe that, apply this formula. N is equal to 34, R is equal to 5. So N plus 1 means that 35 C5. 35 C4. Remaining terms are as it is. 37 C4 plus 38 C4. For these 3 terms, we have to consider 36 C5, 36 C4 plus 37 C4, 38 C4. Again for these 2 terms, 37 C5, same formula, 38 C4. For these 3, N plus NCR, N is 37, R is 5. So N plus 1 is 38 C5 plus this is 38 C4, right? 38 C4. So that is equal to, again apply the formula, 39 C5. So that is the value of that. Next to last question in this one. Yeah. Now last question is this is important theorem. Let us consider LHS. LHS is equal to 4nC2n by 2nCn. So that is equal to, we know that NCR formula is n factorial by n minus r factorial into r factorial. Let us apply the same formula here, 4n factorial by 4n minus 2n factorial n minus r factorial into 2n factorial by the denominator 2n factorial by 2n minus n factorial into n factorial. Once observe that this is equal to 4n factorial this comes to the numerator. So 2n minus n is n factorial into n factorial by 4n minus 2n, 2n factorial into 2n factorial into 2n factorial. This comes here, right? 2n factorial. So once see this one, 4n factorial can be written as 4n, 4n minus 1, 4n minus 2, and so on, 4, 3, 2, 1 into n factorial whole square. This is 2n factorial whole square, right? So this can be 2n factorial whole square. This 2n factorial is as it is here. So 2n factorial whole square, this is 2n into 2n minus 1 into 2n minus 2 into and so on, 4, 3, 2, 1. Once observe that in 4n factorial we have 4n terms, right? Now I am going to mark the alternate terms. So alternate terms mean that out of 4n terms, if alternate terms are marked, we have 2n terms. From these 2n terms, from each term I am bringing 2 common. It means that 4n can be written as 2 into 2n. This is written as 2 into 2n minus 1. Mean that such n's are 2n terms are there, right? Such n's are 2 power 2n, 2 into 2 into 2 into 2, 2n times. So when in these terms, when what is that, 2 is common, we have 2n, 2n minus 1, 2n minus 3, and so on. We have 2 and 1. Remaining thing is 4n minus 1, 4n minus 3, and so on, 3, 1 into n factorial whole square by same concept. 2n terms are there. Consecutive terms mean the alternate terms are marked. So out of 2n, alternate means that half of that. So from these 2 terms bringing n common, 2 common, it becomes 2 power n. Remaining terms are 2n minus 1, 2n minus 3, and so on. What is that? And so on now. 3, 1, this one. Next remaining terms are n into n minus 1, n minus 2, and so on, 3, 2, 1. For these 3 terms, whole square is there. That is 2n factorial. 2n factorial. Once let us write, this is the important stuff. This can be written as 2n factorial. Remaining terms are 4n minus 1, 4n minus 3, and so on, 5, 3, 1 into n factorial whole square is there. In the denominator whole square is there. Whole square comes to these 3 terms. So this 1 2 power 2n. This is keep it like that. 2n minus 1, 2n minus 3, and so on, 5, 3, 1 whole square. So that is equal, this is n factorial, right? N factorial whole square, 2n factorial as it is, n factorial whole square, n factorial whole square, 2n factorial, 2n factorial. So this is the right hand side. This completes the theorem.